Namaste. So in the last video, I talked about common knowledge representation mechanisms. So let me extend that thought a little more and look at some specialized processes and how we humans are able to look at it. So one important point for you to remember is that when I talk about AI, we are talking about building a human-like or at least to the capability of human intelligence in a computer. Okay, so remember that any human being is capable of doing a wide variety of tasks, and the same person can learn and become a good doctor. He can also become a good engineer. He might also be a good artist. Okay, so he given maybe some adequate domain knowledge and some training, we are able to adapt and become different capabilities, and all these capabilities can even exist simultaneously, right? So it is not that when I become a doctor I forget everything else and I can only do treatment, and that too I don't treat only one type of diseases. I am able to understand, I know the human physiology and all the dependencies, so I can do some reasoning and say, okay, this doesn't possibly doesn't it's not quite this type, so maybe you should go to somebody else. So the intelligence or the processing that I am able to do, or many human beings are able to do, is a little quite varied. You do your regular problem solving. If your kid comes and asks you a question, you would answer them. You would do your household related things, your investments, and your office related activities, your day-to-day plan activities. All of these, and many of them are the AI problems that I talked about earlier. And we are able to do all of this. So, whereas when we talk about AI systems today, we are talking about very narrow focused systems. Of course, Gen AI is trying to do something a little bit broader, but even there, it is still very restricted capability that we are seeing. So, whereas the focus of AI has always been to build general purpose intelligence. Okay, so the AI itself, the term itself meant general intelligence, but today, because of the proliferation of the specialized AI systems, we now coined a new term called artificial general intelligence. Okay, so something that maybe again we'll come back to later on. So if I want to do something like that, I need to look at the kind of knowledge that I need. Okay. So one or two types I want to specifically talk about. For example, our spatial sense. So when I'm looking at the things around, I'm creating a kind of a spatial model of what I see. So when I see the front of a book on my shelf, I know kind of what lies behind the book along is there. There's usually no space behind it. There will be a wall or the cupboard will end there, and behind that cupboard there could be space. Okay, and there is a chair, and how much space, and you can walk behind the chair. So there is a lot of spatial knowledge that we bring in, and that allows us to do some amount of reasoning, how to find a path when you're driving a car, and when you see a vehicle behind that, you don't see that at the end of the world, right? So you know that beyond that vehicle, whatever, there will be something, and you can estimate that whether it is a wall, whether there is a footpath, there will be something else there, all of that. So you are able to create a spatial model of the world. Okay, and a similar problem is also there with the time. So when somebody tells you that, but I met you before you went to US. No, but I went to US in December, and before that we had. So you are talking about time points and time intervals. Okay, and that's a very different kind of animals than the normal objects and classes that we talk about. Well, they are factors. When you say a pen, they have a fixed structure. You can understand, but time intervals have dependencies among them. So this interval and another interval one interval can precede, that means just touch and start the next interval. They can overlap, they can end, they can overlap in the beginning, they can overlap at the end. So these capability to understand is very important to, for example, when I met you, you were in the midst of your pregnancy. So there's a pregnancy itself is an interval, and within that, I'm giving a sub interval, and but you know that that interval is within the this longer interval. Or when I met you, you were actually in the supermarket, you were buying something. So this kind of dealing with the time points and time intervals is something that we have extremely good capability for. Now, that ability to reason with those intervals is also important for answering questions to understand when somebody says something. So this is the temporal reasoning. What I said earlier was the spatial reasoning. And these capabilities are not very trivial. So people have come up with what is called temporal logic, so which defines the dependencies or relationship between two different time intervals, or the time point and interval, and so on. Okay, and so there is a temporal reasoning mechanism which allows you to look at this temporal information and ask the question, did this person meet person Y? So you look at all the various intervals talked about and conclude that this person's time was strictly disjoint from the interval that the other person was here, so a meeting would not have taken place. So this is the level of sophisticated reasoning that we are able to do with this kind of knowledge. And similar kind of things are also there for not what is called non-monotonic logic. So logic is usually monotonous in the sense if something is true, it will remain true, for an indefinite period of time. Whereas in non-monotonic logic, something is true, it can become false, or something which is false today can become true later on, and I should be able to revise my belief. So if I decide that, okay, I'm going to go to market because I think today, markets will be open, and then as I plan, somebody tells me that, okay, today is a holiday and there is a special occasion, so most of the markets are not going to be open today. So then I know I should now change my plan to go to market today, and maybe I'll shift it to tomorrow, or maybe I'll go and do something, order things online or whatever. So your chain of reasoning gets modified when the information on which it is built can be changed. That's what non-monotonicity brings in, right? And similarly, incompleteness can also be linked with this, because today it is incomplete, but as I work through the things, I might get more information. Like a doctor gives you some medicines today, but then you get a blood test report or your X-ray report, and then he actually modifies it and say, no, don't take that because I think this is very unlikely, so you go and do this. So this ability to make changes in our plans and our reasoning mechanisms with additional or changing inputs is also a tremendous capability that we have. Now, question is that, or at least the early belief in AI was that you will need to have a mechanism which can deal with all these knowledge and be able to reason with them. So, knowledge representation and reasoning. Okay, these were very, very key element of building intelligence. Okay, and if you again bring it back to today's AI, all that is kind of hidden. So where is all this sitting there? They are all sitting in your data. Usually relational data. If you take data science related things or data deep learning models, there are these input records, okay, which are relatively flat structure for every instance. And it's also, if you look at something like Gen AI, it may be web records, but no one is looking at the concept being captured by in a paragraph, for example. We look at the paragraph as just a sequence of words. And maybe some level word embedding and all that is trying to capture that knowledge. But the complexity that is inherent in when we make a mental model of the world, temporal, spatial, non-monotonicity and all that, is possibly unlikely to come out of this. Does it cause a problem in realizing AGI? We don't know. I do tend to think that there are issues, but that's a challenge that that today's AI systems are facing. Okay, so anyway, so the point was that there are different types of knowledge that we deal with, and we brought in mechanisms. They are not full-fledged or they are not fully integrated mechanisms, but there is a lot of work being done in understanding those different types of knowledge and capturing them suitably into to build an AI system in those days. So the AI that we all used to do work with was the search mechanism, a knowledge representation, and there's a reasoning mechanism, and they all to talk to each other to solve a problem. Okay, so we'll take up this thread further in the following videos. Thank you.